means maybe your workstation. Okay, with this background, we'll jump into the preprocessor, and we'll try to see like how we can set up a model for the crash. Okay, so now I'll launch the HyperMesh. Okay, so once I launch HyperMesh, as you're already using HyperMesh for meshing or for preparing the deck for any other different solvers, you can see the different solver options here. So here I'm picking radios, and under radios also you can see different options which are available. So this just means like now I have opened the HyperMesh with version 11 with the latest patch 130, but I have an option of preparing the deck for a earlier solver version as well. Like if I select radius and block 100, it means like I'm using HyperMesh 11, but my solver, but the deck, what I'm preparing, it will be as per the version 10. So that is what it means. Similarly, like we had the earlier version 90, 51, and all that. So I'll be using the latest one. So it is block 110. Okay. It means the solver version is 11. Okay, now I will try to import a HM model. Okay, so now I have a simple car model, of course not the complete one, and a very crude. So I have a car model. So if you see here, it okay, let me delete this as well. Okay, if you see here, it just has components, so nothing else. It doesn't have any material property contact, nothing is there. It just has the components, and it has the assembly which is being created. So I have a separate assembly for outer skin, and I have a separate assembly for tires. Let me mask these widgets. Okay, so I have created a separate assembly for structures and a separate assembly for panels and some engine parts and the hub of the wheels. So this is how I have created the assemblies. So apart from this, if I try to look it in terms of the types of element, if I say the springs, then I'll switch on the element handles. So there are some springs for the which are, as I have seen this model, so there are some springs which are at the suspension location. So these are just springs without any properties. And similarly, there are some springs which have used for the joint application, again without any properties. So for as of now, the information is like it has some springs in the model, and it has some beams for the structural representation purposes. So there are some beams in the model, and of course the entire BW, and there are some part which are 3D. Okay, fine. So my scheme is something like this. First I will create the some list of I'll create some list of properties, and I'll assign that, and after that I'll create some list of materials, and I will assign that. So this is the scheme. So first I will create properties. So in the model page I'm going to create, and I'll be going to properties. So when I open that, I will tick this flag so that the card edit window will pop up once I close this. So here the type is surface. So first let me create maybe a shell with 0.8. So this is just a name. I have not entered any thickness here. So my card image will be P1 shell. So I will say create. So it has opened the card editor tab for me. As I mentioned, I will be using a formulation I shell 24, that is here, and number of integration point will be 5. So this is the number of integration point which it is advisable to use always 5, unless you are dealing with any membrane, that sort of thing. For all our the structural application, all our panels will be having number of integration point 5. And thickness I will specify 0.8. So this is the tab where I am specifying the thickness, which is very important parameter for the property card. Okay, I created one property, so return. Okay, so I try to create one more. Okay, so which is maybe, okay, I'll go with this same as, so that I don't have to enter the formulation and the other tabs. So I'll create one more with 1.2, create. So since I used same as, like I have the formulation already selected, number of integration point already selected, I have to just change the thickness, which is 1.2, return. So one more, create property, same as, and this time I want to create it with the 1 mm thickness, create, and thickness is 1 mm. Okay, so I have created for all the shells. Okay, so now my idea is, for all the outer skin, isolate. Sorry. For all the outer skin, I want to assign this thickness of 0.8. So I have displayed, now I have displayed only the outer skin. There are different ways of updating these properties. You may be using, you may be already using some different ways. Like we can go to the components, we can pick the parts, and we can assign that property. So there are some 2-3 methods. Here I'm just trying to show one of that method which I frequently use. So which is, I'll go to utility. So I'll open the component table. So it will show the component table for the parts which are already displayed here. So I will make it as a table editable. It is already a, sorry, table editable, so that it will come something like this. So now I'll pick all this, and here the property is this one. I'll say set yes. So all the properties of these parts are changed. Okay. So similarly I'll do for the rest. I will go to I'll go to tires, and for tires as of now I'll use the thickness as only maybe 1 mm. So I'll again go to utility, component table, so I'll select everything and 1, set yes. Okay, so structures next. So in the structures, I don't want that. I think that springs have gone into that structures while doing the assembly. So I'll just mask it. Components, element, spring. So I don't want them. Okay. So again in the component table, I'll set everything here and assign the thickness as 1.2. Set. It is taking some time, as you can see here. It is running the process and assigning the thickness for assigning the property for all the components. Okay, done. Do I have any other assembly? Yeah, I have the inner panels. Sorry. So I have the inner panels for which I'll assign the thickness as again 1 mm. So I'll go to model, utility, component table. So all this 1 mm set. Okay. And okay, so here I have some discrepancies in the sense like here I also have some solid part, so which I want to neglect. So again I'll go to mask, 3D's mask. Okay. So all these things I'll push it for 1 mm because anyway I'll be making these material as rigid. So in that sense I'll just assign the property as these are shells, so it requires a property, but that I'll be making it as rigid at the later stage. So as of now I'll assign the property as 1 mm. Okay. Okay. So these are 1D elements whose property as of now I am not updating because I am dealing only with the shells now. Okay, so now I have to create one more property for the solids. So I have to create maybe property. Now it is volume solid 1. Card image is P14 solid. So this is what I was referring it as a very generic solid. Okay. Create. And I will use the formulation 24. So nothing else here. Return. Here I did some mistake while naming it. That's why it is coming it as so it is coming as shell 1. I'll just rename it. Okay. Okay, so now here I will isolate the solid parts. These are the solid parts for which I will assign the material, for which I will assign the property component table. So these solids, solid 1, set. Yes. Okay. So now in the model, so let me show till here. Okay, and if I go to utility component table, just a minute. So these joints, if you remember, like we masked this since they are one element. So apart from that, so apart from these joints and this beam, all has one or the other properties. So property is there for all the components. So this is one good way to ensure like all your component has the properties. Otherwise, it will throw an error when you try to run the solver. And it is also showing the thickness of the components. Okay, close this. And now I'll try to create the 1D properties, which I will require for some suspension. I'll be requiring for some joints, and I'll also create a property for the beam, which I need to assign it for the structural members. Okay, this is important because you might have already experienced the creation of the shell and solid properties for different solvers. So here the difference was only the formulation, how you pick, and regarding the number of integration maybe. So apart from that, you are knowing how to create the properties and assign it. Now I'll create the 1D properties, which will be definitely different than other solvers. Okay, create properties. So now I'm trying to create suspension property. So as I mentioned earlier, suspension means essentially we'll go with type 4 spring, and you can use type 13 spring as well, but here I'm going with the type 4 spring. So so the type will be a line element. So here I will call it as sus. Okay, and card image will be P4 spring. So for suspension I'm going with the P4 spring here. Okay, create, and here you have an option. Like here you can see the stiffness tab K, and here you can see the damping constant. So here if you define any value, then that spring will behave something like a linear spring. So here if I specify, let's say some 10, so it becomes a linear unit. So for say like 10 mm displacement, you're applying 1 Newton. So as you increase your load, so you'll get the fixed amount of displacement. So it behaves in that manner. But normally for suspension, like we don't do it in such a way, because our suspension will not be a linear values. Suspension will be normally a non-linear. So stiffness requires force versus displacement curve, and damping requires force versus velocity curve. So for that, we have an option here where we can input a function. So in the stiffness function, I'll be specifying force versus displacement curve, and if I have the damping as well, then I can use force versus velocity curve. But here, my intention is to use force versus displacement curve. But as of now, I don't have the curve data. So what I am doing is I am coming out of this. So suspension property is already created, but yet the curve data is not there. So I'm trying to create a curve. So for that, I'm going with again, there are many options to create the curve. So now I am introducing a new thing. I can switch on this view and solver browser. So here it will show all the cards with respect to the radius. So you can pick up any card and you can create, or if any things which are already existing, then you can try to modify that. So this is a very good way of maybe learning HyperMesh if you already know the radius. Say like if you already know like in radius you need a curve, then I'm going by that method now. Now I need a curve. So what I will do is I'll go to right click, create, and here I will go with function. So here we call it as a function. So I'll go to this function. So directly your card editor is open now. So it is asking for there I press the tab new and I'll give a name, suspension, proceed. I'll select it, enter the values, maybe at 0 displacement it is 0. So when my force is, let's say it is 100,000 newtons or 1 kilonewton, my displacement may be 10 mm, and when it is 2000 it is 15. So when it is 3000 it is 20, so on and so forth. So here I want to show one more thing. Let's say my force is enormous, or maybe a still higher value. Okay, let me show this curve. Update. Okay, I'll try to change a color. Okay, so here what I'm doing is I have created a ramp here. So my intention is, I know my spring locks after say 20 mm. You know, like a suspension will be having a behavior something like after moving certain amount of displacement it will lock. So this is something very similar. I'm trying to do it here. So till 20 mm it moved, and after that normally this is not the value what we give. We give a very high value. Here I have just specified 15,000 because if I put very high value here you cannot see the graph. Normally we put a very high value. Let me make it something like this. Then if I say update, see, now after moving 20 mm it requires an enormous force to travel this next very small value. So thereby we are locking the spring and we are making it to behave something like actual suspension. Okay, now I just created the curve here. Okay, let me close it. Okay, now I'll again go back to my model property. So here I do card edit. Sorry, I'll close this one. That was still open. I said card edit, so I have this tab now. So in this I'll call that function. I'll call the suspension function. Okay, I'm done with it. Similarly, this calling function is very similar in many other different places also. So that we'll see as we go along, because we have to call the function sometimes in the material, sometimes in the loading at many places. Okay, so we have created the suspension property, which will assign it to the suspensions. Okay, now I want to show you to one specific location where I have joints. So here, if you see, like I have a spring here, I have one spring here, and I have the other spring here. So this is a control arm where it is expected to work like a revolute joint. It means it should allow the rotation only along z-axis. So at these two places, it should allow the other component to rotate in z-axis. So that is the purpose. So for this joint, we will use type-8 spring. As I mentioned in my PPT slide, so for joints, we'll be using the type-8 spring, and this type-8 spring has to be of 0 length. So that is one thing to keep in mind. So if I go to this particular spring, so I just want to mask other components so that you can see it. Okay, I have this type-8 spring here. I will just switch on the coincident picking option. Coincident picking. So if you just see it here, I have two nodes by 261 and 260. So this is a 0 length spring whose one arm is connected to one leg of a rigid, and the other arm is connected to other leg of a rigid. You will see that as well. I am going with find attached elements, find. So For the purpose of your understanding, I'll just try to change maybe color. Sorry, to change the color, I require a separate component which I don't want to create as of now. But if you see it here, like so, this is so you have one leg which is coming from this rigid, and you have other leg which is coming from the other rigid. They are not equivalent, so there are two separate nodes over this location, and so in between that we have this zero length spring, which is a type 8 spring. So this is regarding the creation part. And one more thing which you have to also observe here is you should always connect the slave node or the dependent node of a rigid, not the master node. So you have the independent node here, you have the independent node of this one here. So for using the spring connection, you have to always use the dependent node. This thing you have to keep in mind. I will show that at one more location more precisely, but at this point, the thing what you have to keep in mind is it has to be always between nothing should be connected to the master node of a rigid or the independent node of a rigid. That's why here I have used slave node of a rigid to connect the legs of a spring. Okay. So now coming back to the property, now I have created an element, but that doesn't have any property. That doesn't have in this case, it doesn't have any revolute property. So now what I'm doing is, I'll create one more property. Create property, again line element. So it is joined. It is joined here, and for joint I will use type 8 spring. And one more condition is type 8 spring always has to be of zero length, as you're seeing it here, whereas type 4, type 13, type 12 and all other spring should have a definite length. They cannot be of zero length, but type 8 has to be of zero length. So this is one differentiation. And the other differentiation is all other spring follow their own local coordinate system. So node 1 to node 2 will be always x in the case of other spring, except here in type 8, by default it follows the global coordinate system. You have an option to select this cube, that is a different thing, but by default type 8 will work in the global coordinate system. Why I am telling that? Because now here I have selected the card image as type 8 spring. Let's say create. Now my intention is it should rotate in, it should be able to freely rotate in along Z. If you see the vehicle, in the vehicle Z is towards upwards, and this mechanism, this revolute mechanism has to work in Z rotation. So for that what I am doing is, in all other direction I am giving high stiffness, maybe say 1 e power 5. So this is in the tension. So not in tension. In this case it is along x direction. It is on x direction, and this is in the y, again high stiffness. This is along z, again high stiffness. Okay. So as I mentioned, in z rotation, which is, so this is along x rotation, which is again high stiffness, and y rotation again high. So this is the z rotation, which I will keep it as 0. So for this spring to rotate in z direction, there is no stiffness, so that it can easily rotate and work something like a joint. So this is how I am creating a joint. So let's say if you want a cylindrical joint, then cylindrical joint is a combination of a revolute joint, and you require a transverse movement along its axis. So what I will do is, so rotation along, stiffness along z rotation also I'll keep it as 0, and translation along z also I'll keep it as 0. Thereby I will achieve a cylindrical joint. And if you want spherical joint, all the rotation, all the stiffness along rotation, you have to keep it 0 in that way. Okay. So here stiffness along z rotation, I have kept it as 0. Here I'm going with linear properties. I don't require any function as such here. If you require by any chance, you also have an option to input the function. But in this case, I'm just going with the linear properties, where all other direction has high stiffness, whereas in z rotation, it doesn't have any stiffness because my mechanism has to work along z rotation. Okay, now I have the property ready for those springs, and now I have the property ready for the suspension as well. So let's go ahead and assign those properties. I will go to mask and maybe isolate only springs. Okay, so here I have 2 suspension springs and 4 joints. All are revolute joint at control hub. Okay. So now I will assign the properties in a different way. Component, update, maybe these 2 properties. So the property will be suspension. And you have to specify no material here. And one thing to keep in mind is, when I say update and edit, if this is not on, you have to voluntarily go and take this and make it as declare it as spring center bit. It is always a good practice. Okay, written, and just ensure that you are seeing a part here. Okay, so I have updated the suspension properties for these 2 things. Now I will update these components. I refreshed it so that earlier selection was still there, so I refreshed it. Okay, property, and I will select joint. Again, no material, updated it, this is on. Perfect. Okay, now I have updated the properties for all the springs which are there in my model. The next activity is for the beams. So I have some beams that they are the structural beams at many locations for different applications. So I'm not going in detail. This is, I think, for the hood attachment, maybe, but I'm not going in detail. I will just create a beam property and update the same property for all these components. Okay, so I'll again go to, okay, before going there, I require a beam section because beams will be requiring properties something like areas and inertias in XYZ directions. So for that, I'll go to 1D HyperBeam standard section, maybe a solid circular, create. So maybe this is with let's say 5. So you can see it in the right hand side. You have the property here which will change as per the property which has selected. So I have the areas and moment of inertia along the different axes. So these are the parameters which are required for beam property. So now I have a beam section which is already created. So I'll come back to my model. Okay, I'm back to my model. So I have the section created here. Now I will create the property again, property line. So this time it is beam. It is just a name, but here I will select the proper card image. The card image will be P3 beam. P3 beam. So create. It has opened the card for me. So I'm calling the HyperBeam section here, so which has updated all this information for me. And you have the pin flag to play with if you want to create some mechanism here, which I'm not doing it here. It is not my purpose, but it has updated all the parameters which are required for this beam property. Okay, I'm done with it. Written. Okay, so I have the beam property created, which I have to update to these components. So again, I'll go with this method. Components, updates. So all these components, all these component property is beam. Just want to be sure that all are beam. There are no springs. Okay, and earlier I mentioned like for spring, it doesn't require material and you have to go inside and take the tab. But beam, it requires a material. As of now, we don't have any material in our model which we have to create it. But just keep in mind that beam requires a material. Okay, now I have just updated the beam component with the right property. Okay, written. Okay. So now I have property for all the different types of elements which are there in my model. Fine. Now my next task is to create the material. So I'll do that. So create material. First I will create a maybe elastic material. Elastic one. Card image for elastic is M1 elastic. Again, this tag has to be on so that it will automatically open the card reader for me. Create. So Young's modulus. Sorry, first the density 7.86 e power minus 9. Okay. Now since I came to element tab now, here the one more thing to keep in mind is we have not declared the unit system here. So as you do it in the other server, like here also, we have to maintain the unit consistency. So here I'm trying to maintain the units as Newton, millimeter, second, and tons. So the density, what you're seeing it here, it is the tons per mm cube, and the Young's modulus, what you will see, it will be in MPa, 2.1 e power 5. So we have to maintain the unit consistency. So this being elastic material, it just requires simple three basic parameters. So I created that. Okay, fine. Written. I will create one more material. Again elastic. So I just want to have a different material for the tires. I'll explain it as I go along. I'm just creating one more elastic material. So create. So maybe with very low density, maybe say 1 e power minus 9, and Young's modulus maybe 2100, which I will later use it for a rubber kind of material. Actually, I had to use the hyperelastic material over there, but since I'm not interested in anything in that wheels, I'm just using the elastic material here. Okay, I created two elastic material. Now I will create a elastoplastic Johnson Cook material. Card image is it is lot 2 material. It is Pass Johns. Created it. So density is 7.86 equal minus 9. Young's modulus is 2.1 or 5. Mu is 0.3. So this we entered in even in our elastic material, but here the important parameters are this Young's modulus. This is the yield stress, maybe 190. This is hardening parameter, maybe 250. Hardening exponent 0.1, and ultimate stress, for which you have to drag this tab, and ultimate stress maybe say 350. Okay, now I created the Johnson Cook material. So we have three materials here now. I'll create one last material, which is again in the elastoplastic category. I will create mat law 36. So I created just an elastic material, and I created a basic elastoplastic material, and this is a more comprehensive elastoplastic material. So I'll say create. Okay, I have to change the name. Stamp. So this is the card image. Create. So it requires basic parameters. 2.1 profile. 9.86. And here, as I mentioned, like here it requires the true stress versus plastic strain curve to be entered. And if you have strain dependent stress strain data, then that also you can put in this one. So if I say it as like 1, I have only one stress strain curve for a material. Similarly, like I can enter, maybe if I put 10, you can see it here, I have an option to input 10 curves in this material. So normally in the solver, like when we are explaining this material, we'll explain what are the strain dependent. Uh, so how we get this strain dependent strain data and how we can use this. So here I'm just trying to create only one stress strain curve. I specified the number of curve which I'll be inputting here is 1. So at the later stage, I have to call that function here. Again here, I don't have the function ready. So what I'm doing is I'm returning as of now, and I'll go to my solver browser, create function. So there are two functions there are one function which I earlier used for suspension. Now I am creating a new function which I will use for law 36. Some name, proceed. I'll pick that. So at 0, it is 200. So this is one important point from the solver perspective. Here what I'm telling is at 0 strain, my yield is, at 0 plastic strain, my yield is say 200. So my curve has to start from positive yield. It means it has to start from something like this. Okay. So for maybe 0.0 to 30, 0.21, so you're seeing it. It is starting from 200, that's why it is looking like this. If it is 0, 0, like it will look, the curve is somewhere from here. Okay, so I just want to end this curve till the end. Maybe my ultimate is 0.2370 and 1,370. Okay, so I have ramped and I made it as flat. So this is my curve. Close. Now I will again come back to the material. I'll do the card edit. For this material now I have to link that curve. So card edit. This window was still open. Okay. So in the functions, sorry, not this function. Okay, so in this one you have to call that function what I just created. So I created this function which I am calling it here. Okay. Okay, so I created all the material now. Now it is my job to assign the material for the components. So I'll again go by the same method as I did for the properties. So first, my idea is for all this, say like outer, structure and inner. So for all this, I will assign this MATLAB 36, which is a very comprehensive uh, material. Just a minute, I don't know why I'm seeing the engine here, which should not be the case. I don't want to assign that material to this engine. Right. Okay. Okay, I'm seeing some beam elements, so I have to be careful here. Mask, so rigids, no springs, no wound elements. Okay. Okay, I think I'm doing some mistake here in terms of switching on the model. So what I will do now is I'll go with display all, so everything is on now. So I will select whatever I require, so which is outer skin, structure and inner panel, and I will say isolate, isolate only. And as you know, like in one of that assembly I had the spring element, which I will go separately and mask those springs. Okay, now I'm sure that my assembly has only the outer skin, structure and panel, and anyway those spring elements I have removed it. Now what I'm doing is I'm trying to assign the material. Okay, I'll again go to utility, come out of this component table, so select everything, and now what I'm updating, it is not property, it is material, it is tabulated. Set yes. So now the material is getting assigned. Yeah, it is done. Okay, it is done. So now in the model I'll display only the beams. Okay, let me display only tires, and for these tires I will assign those elastic property which I created. Okay, model utility component table. So for these things I will assign that elastic 2 which has the rubber properties. Set. Okay, done. And so now outskin tire structure engine panel is over. So engine parts, select only engine parts. Okay, so for these things I will go with the first elastic material what I created. So I'll go with the mod utility component table, so all these things. So it is elastic. Set. Okay, so the material has been assigned to all those things. Fine. Again in the model, so I have those beam elements. As I mentioned, beam requires the material, so I'll go here and I will isolate the, first I have to add it. Okay, add handles, add. I'm just trying to add those. I'm doing something here. Okay. So now I isolate on the elements. Okay, I'm seeing all the beams here, for which I had to update the material, for which I'll select Johnson Cook. So utility, component table. So for all this, material will be Johnson Cook, set yes. Okay. Okay. Go to more. Okay. So now I just want to display everything. So none, all, and I want to see the component table for my satisfaction that all the component has okay. So for these beams, I think I have not assigned the property which I had to do. So this is the good thing about seeing the component table at the end, which will give a confidence. So now I have caught, if you see here, I have caught that beams, anyway, rigid doesn't require anything, but beams doesn't have a property which it should have, but beams have a material which I just now assigned it. So okay, so one thing is for the beams I have to assign the property. Now I list as per the material. So materials, joint doesn't have and spring doesn't have material, which is true. So apart from that, all other part has one or the other material, which is correct. Fine. So my only task is for the beam I have to update the property. Okay, now I again go to mask, isolate on the elements which are beams here. So utility, component table. So for these beams, property is beam, set yes. Okay, fine. Okay, so now my model has it's a living model which has the property and material. Okay, one thing which is apart from these things are I have to just do the card edit of this rigid. So I have the rigids here. Just do I want to see the component of this component update. I will track where is this rigid. Rigids, select. Okay, this is one very important thing. This rigid, we have created a separate component just for the sake of one particular separation in the color. Its card image should not be part as it is here, because once you call it as a part, Reduce will expect a property and a material for this part. So if you declare it as a part and if you leave it blank without any material and property, then it will give an error. So for rigids especially, we should make it as no card image. It means it's not a part. So this is one important thing. Update. Okay, fine. Okay, so I'm done up to one extent.